Good morning to all. My name is HCM Swami, working as a professor and also a freelance engineering in the field of structural and project management. Today, as according to our schedule, I am going to demonstrate the mathematical abilities required for a student of second pre-university. That is the concern of this video. This video is of 45 minutes, and each day I am posting a new video of continuation of the previous lectures. Please kindly see the Facebook of my profile, and please kindly follow the video what I am going to deliver. To start with, I am going to start with a work in mathematics, that is with matrix algebra. Please kindly bear with me because I am also new with this system of arrangement. It will take 2 to 3 classes to adjust myself to this system. Now, this is the third chapter in pre-university curriculum. First one is congruences. Second one is groups. Third one is matrix algebra. Now, just in this video, I'm going to demonstrate what is a matrix is and what are the different types of matrix which we are using in our curriculum or in our studies. First, I am going to define a matrix. What is a matrix? Matrix is a rectangular array. Rectangular array. Array means arrangement. Rectangular arrangement of numbers enclosed within brackets. So brackets are nothing but this is called small bracket, small bracket. This is called big bracket. And this is called flower bracket. And this is called line bracket or vertical bracket. So matrix is a rectangular arrangement of numbers enclosed within brackets. Either it may be a small bracket, or it may be a big bracket, or it is a flower bracket or a line bracket. Now, how the matrix looks like. So I will take one example of the matrix. Example of the matrix. I'm naming the matrix as A, and it looks like this. So I will write the numbers 1, 2, 3, 5, 8, 4. This is a matrix. So matrix, so here you please observe, it is an arrangement of numbers. Arrangement of numbers enclosed within brackets. Always matrix is denoted by a capital letter. I am denoting the matrix by a capital letter and enclosing the arrangement in a bracket. In this one, this 1, 2, 3, 4, 5, 8 are called as elements of the matrix. They are known as elements of the matrix. Elements of the matrix. Elements of the matrix. Elements of the matrix. So these elements are arranged in rows and columns. There are two rows. Observe, this is first row. This is second row. There are two rows. And how many columns are there? 1, 2, 3 columns are there. So arrangement of numbers in rows and columns constitute a matrix. Horizontal lines are known as, this is horizontal line. This is horizontal arrangement called row. And vertical lines are called columns. So here the arrangement of numbers are in terms of rows and columns. So how to define the size of the matrix? Size of the matrix is nothing but number of rows into number of columns, or order of the matrix is equal to number of rows into number of columns. So I will write here order of the matrix is equal to order of the matrix. Order of the matrix is equal to rows into columns. Try to understand. Order of the matrix is equal to number of rows into number of columns. How many rows are there? There are two rows, one row, two rows. There are two rows. And how many columns are there? 1, 2, 3 columns are there. So what is the order of the matrix? Order of the matrix. Order of the matrix is equal to 2 into 3. There are two rows and three columns. So again, I'm concluding with a one point. What is a matrix? Matrix is a rectangular array of numbers enclosed within brackets, and the numbers are arranged in number of rows and number of columns. So try to understand, matrix is only an arrangement of numbers. Either it may be a rectangular matrix or a square matrix or a row matrix or a column. That I am going to define next point. In this one, this is the first element of the matrix. This is the second element of the matrix. This is the third element of the matrix. Similarly, this is the fourth element, fifth element, sixth element. These are the elements of the matrix. First element is represented as A, 1, 1. That is, A is the first element. Number 1 is row, 1 is column. So try to understand. I will define in general A, in general, A, I, J. I'm going to define as A, I, J. What is I? I is called rows. I is called rows. What is column? What is J? J is called columns. Columns. So first row, first column. First row. This is first. This is A. First row, second column. This is first row, third column. Try to understand. First row, first column. First row, second column. 1, 2, second column. First row, third column. Similarly, come to this one. A, second row, first column. A, second row, second column. A, second row, third column. Okay, so entire matrix is arranged like this. Now, in general, I am writing the matrix like this. Matrix like this. 1 minute. 1 minute. I will write the matrix like this. Now, generally, I'm writing the entire matrix. So matrix is denoted by a capital letter. I'm right. Matrix is denoted by a capital letter. That I will write down. Matrix will be written by a capital letter, and the elements are arranged like this. A is the first element, first row, first column. Second one, A, first row, second column. A, first row, third column. Similarly, A, second row, first column. A, second row, second column. A, second row, third column. Then A, third row, first column. A, third row, second column. A, third row, third column. This is the matrix. Now, I am restricting myself to the 3 by 3 matrix. So, what is the order? So, what is the order of the matrix? What is the order? Number of rows into number of columns. How many rows are there? This is the first one row, second row, third row. How many columns are there? First column, second column, third column. There are 3 columns. So, order of the matrix is equal to number of rows into number of columns. What is the order of the matrix? Number of rows into number of columns. Number of columns. Number of rows. So the order of the matrix is equal to 3 by 3. 3 by 3. Now, so this is a square matrix because number of rows is equal to number of columns. So it is a square matrix. For example, again I am saying A, I, J is a common notation. A is the element, I is the row, J is the column. That also to be noted down. I, what is the I? I is the row. Row means this horizontal line. Horizontal line. There is a row. What is the J? J is a column. Column. This is the column. Column. Okay. So matrix is a rectangular arrangement of numbers enclosed within brackets. This is the first definition we have to know. Next we will go for the next idea. Now, different types of matrix. Different types of matrix. What are the different types of matrix? Now we will go for different types of matrix. Different types of matrix. First called row matrix. Row matrix. This you are already studied in your 10th standard, but I am revising with brief examples. Row matrix. What is a row matrix? It contains a single row. It contains a single row. 1, 5, 7. This is a row matrix. Denoted by a capital letter. Elements are this and capital letter. How many rows are there? One row. Only one row. Only one row. How many columns are there? 1, 2, 3 columns. What is the order of the matrix? Number of rows into number of columns. How many rows? 1 row, 3 column. 1 row, 3 column. It's a row matrix. Next one is called what? Column matrix. Column matrix. Column matrix. So this is indicated by capital letter B, column matrix. So this is a column matrix. 5 minus 1, 8 is a column matrix. Now, what is the order? Number of rows into number of columns. How many rows are there? 1, 2, 3 rows. 3 rows. And how many column? Only one column. So order of the matrix is 3 into 1. 3 into 1. Similarly, we'll go for a rectangular matrix. Rectangular matrix. Rectangular matrix. So I will denote this as C. Rectangular matrix C. Number I will write 1, 5, 7, 8, 2, 5. This is a matrix called rectangular matrix. How many number of rows are there? 3, 1, 2. 2 rows. And how many columns? 1, 2, 3 columns into 3. Order is 2 into 3. Order is 2 into 3. Similarly, we will define a square matrix. Rectangular matrix. In the rectangular matrix, number of rows is not equal to number of columns. Try to understand. Number of rows is not equal to number of columns. It is a square matrix. Square matrix. Number of rows is not equal to number of columns. It is called a square matrix. It is called a rectangular matrix. Number of rows is not equal to number of columns. So it is called a rectangular matrix. Now we will go for a square matrix. Square matrix. Square matrix. What is square matrix? I will say D, square matrix D. So here 5, 2, 3, 1. This is a square matrix. So here number of rows are equal to number of columns. How many rows? 1, 2 rows, 1, 2 columns. So order of matrix is 2 into 2. And also I read a square matrix of order 3. I already explained this in the previous slide, but I will write here. It is a 3 by 3 matrix. So I write -1, 0, 2, 5, 3, 4, 9, 7, 4. This is a square matrix. Number of rows is equal to number of columns. Here also number of rows is equal to number of columns. What is the order of the matrix? 3 by 3. 3 rows and 3 columns. 3 rows and 3 columns. Now I'm going to define zero matrix. I'm going to define a zero matrix. Zero matrix. Zero matrix. It is also known as null matrix. Null matrix. Or it is called void matrix. Void matrix. So zero matrix, null matrix, or void matrix. What is this? I will write a matrix A. It is a zero matrix. Elements are 1, 2, 3, 4, 0. Zero matrix. So it is order 2 rows and 2 columns. 2 by 2. It contains 2 rows and 2 columns. Similarly, we are going to define a 3 into 3 matrix. 0, 0, 0, 0, 0, 0, 0, 0, 0. So what is the order? 3 by 3. What is the matrix name? It is a capital letter 3. It is a zero matrix, null matrix, or void matrix. Even row matrix we can write a row matrix of 0 row matrix, 0, 0, 0, 0 row matrix. Order 1 row, 3 columns, 0 matrix. Similarly, we can write a 0 column matrix. This is a column matrix. Order 3 rows into 1 column. So I will name this as a C. I will name this as a D. These are all zero matrix, or null matrix, or a void matrix. So we can write the matrix containing zeros. They are called null matrix, zero matrix, or void matrix. Similarly, we'll define a matrix called scalar matrix. Before scalar matrix, we'll define a diagonal matrix. So I'll write the diagonal matrix. I will see the I'll write a diagonal matrix. Diagonal matrix. Diagonal matrix. So what is a diagonal matrix? Diagonal matrix is a square matrix. Diagonal matrix is a square matrix in which the principal diagonal elements, in which diagonal matrix is a square matrix in which except the elements on the principal diagonal, all other elements are zeros. What is the principal diagonal? Observe this one. This is a principal diagonal. This is a principal diagonal. Principal diagonal. This is called secondary diagonal. This is called secondary diagonal. Secondary diagonal. So I'm representing a matrix like A. So I will write the same matrix here. It is a matrix in which 1, 0, 0, 0, 2, 0, 0, 0, 5. It is a diagonal matrix. Except the elements of the principal diagonal, all other elements are equal to 0. Try to understand. Here, observe this one. It is a principal diagonal. It's a principal diagonal. 1, 2, 5 is a principal diagonal. A line extending from left topmost to the right bottommost is called a principal diagonal. The direction is in this direction. It is called a principal diagonal element. This line 0 to 0. Observe this one. This is called secondary diagonal elements. Secondary diagonal elements. So 1, 2, 5 is called principal diagonal and 0, 2, 0 is called secondary diagonal. Now try to understand. Again I am saying, if you, it's a 3 by, what is the order? 3 by 3 matrix. This is a 3 by 3 matrix. This is a 3 by 3 matrix. I will take a 2 by 2 matrix. I'll take a 2 by 2 matrix. I'll take a 2 by 2 matrix. 5, 0, 0, 2. Here, this is a principal diagonal. It's a principal diagonal. Except the elements of the principal diagonal, all other elements are equal to zeros. All other elements are equal to zeros. Such a matrix is called diagonal matrix. What is the order? 2 rows into 2 columns. Order of the matrix is 2 by 2. Now, next we'll go for a scalar matrix. Scalar matrix. What is a scalar matrix? Scalar matrix is also a diagonal matrix. Scalar matrix is also a diagonal matrix in which the elements on the principal diagonal are all equal. The elements which are present on the principal diagonal are all equal. So now I am defining a scalar matrix. I will write here scalar matrix. Scalar matrix. In this matrix, so I'll write an example for a scalar matrix. Matrix is, I'll write a matrix as B is equal to, it is a matrix. So 4, 0, 0, 4. What is the order? 2 into 2. So you see, in the scalar matrix, the elements on the principal diagonal are equal. The elements of the principal diagonal are equal. I'll write a 3 by 3 matrix. I'll write a 3 by 3 matrix here. So I'll take a D matrix. I'll write a 5, 0, 0, 0, 5, 0, 0, 0, 5. This is a principal diagonal elements are equal to, they are all equal and their values are 5. So order is 3 by 3, 3 by 3. So diagonal matrix. So what is a scalar matrix? Scalar matrix is a diagonal matrix in which the elements of the principal diagonal are all equal. There is a definition for scalar matrix. This is 2 by 2 matrix. This is 3 by 3 matrix. Now I will go to the other point. Now I will define a unit matrix. Unit matrix or identity matrix. Unit matrix or identity matrix. Identity matrix. What is this unit matrix? Unit matrix or identity matrix is a scalar matrix. Scalar matrix means it is a diagonal matrix in which the elements of the principal diagonal are equal to 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the unit matrix of order 3 into 3. What is this letter? C. I will call this a C matrix. So what is the order? 3 rows into 3 columns. 3 rows into 3 columns. So this is a unit matrix or identity matrix. Similarly, we'll take a 2 by 2 matrix. So I will call it as a D matrix. D matrix. So in this D matrix, I'll give numerals like 1, 0, 0, 1. So here the elements on the principal diagonal are equal to 1. This is called a unit matrix. Unit matrix. What is this order is 2 into 2. 2 into 2. So unit matrix is a diagonal matrix. In terms, it is a scalar matrix also, on which the elements of the principal diagonal are equal to 1. The value of the diagonal matrix elements are equal to 1. I will write another one more example. So 0, 1, 1, 0. This is not a unit matrix. Please observe, this is not a unit matrix because elements of the principal diagonal are not equal to 1. This is not a diagonal matrix. Another example, this is example E. I will take another example, F. F is an example, another example. Here 0, 1, 1, 1. This is also not a unit matrix because the elements on the principal diagonal are not equal, as well as the other elements are equal to be 0. But here they contain numerical values. So the elements on the principal diagonal are not equal to 1. But one is 0, other one is 1. So it is not a unit matrix. I'll write another one more example. G matrix here. 1, 0, 1, 0. This is also not a unit matrix. This is also not a unit matrix, except the elements of the principal diagonal are equal to 1 and other elements are equal to 0. It is called a unit matrix. Now, after defining a unit matrix, we'll define a matrix which is equal. Matrix which are equal matrix. Now, equal matrix. Equal matrix. For example, a matrix A is said to be equal to matrix B. A matrix A is said to be equal to B. When you are saying a matrix A is equal to said to be matrix B, all right, 1, 5, 7, 8. This is a 2 by 2 matrix. Please observe carefully. Please kindly observe carefully. And I am writing another matrix, B matrix, 1, 5, 7, 8. This is called equal matrix. That means first element is equal to first element, second element is equal to second element, third element is equal to third element, fourth element is equal to fourth element. What is the order? 2 into 2, 2 into 2. Now I'll write one more example where A is equal to B. I'll write a matrix 5, 7, 8, 3, 2, 1, 6, 5, 3. This is one matrix. Another matrix I'll write the another matrix X, X, 0, sorry, X, 7, 8, 3, 2, Y, 6, Z, 3. Now, when you say these two matrices are equal, first matrix, this is first 5, here it is X. So X should be equal to 5. So similarly, 7, 7, 8, 8. This is 3, this is 3, this is 2, this is 2. Here 1, Y. So Y is equal to 1. Y is equal to 1. Similarly, 6, 6, 5 is equal to Z. So Z is equal to 5. So if this condition is satisfied, then these two matrices are said to be equal. So the corresponding elements of the matrix A is equal to the corresponding elements of the matrix B. Then only we can say that the two matrices are said to be equal. Now, now there are another two types of matrices are there that I will define in the later part. Now try to understand whatever I have defined here. Please try to go through it. So now a matrix A is equal to matrix B when the corresponding elements are equal. First element, this is a corresponding element first, corresponding element first, corresponding element third, corresponding element third, corresponding element 8, corresponding element 8. So like that, the values of the matrix A is equal to the values of the matrix B, then we can say that both the matrices are equal. Now, after this, I'll write another one thing. How to add the two matrix? How to add the two matrix? Addition of two matrix. How to add the two matrix? So I'll take a matrix A. I'll take a matrix A. So I'll write numericals. Letters. Generalized method. C, D. It is a matrix 2 by 2. 2 rows, 2 columns. This is the matrix B, E, F, G, H. Now, so I want to add the matrix A plus B. I want to add these two matrix is equal to, how to add this one? First element plus first element. So A plus E. A plus E. First element of the first matrix, first element of the second matrix, A plus E. Then second element of this matrix, second element of this matrix, B plus F. Please observe carefully. Then C plus G. C plus G. Then D plus H. D plus H. So the on summation we'll get the number. So what is the order of this matrix? 2 rows, 2 columns. What is the order of the matrix? 2 rows, 2 columns. What is the order of the matrix? 1, 2 rows, 1, 2 columns. 2 rows, 2 columns. So by adding two matrix, we'll get the summation matrix of the same order. Try to understand. I will give another one more example. For example, matrix A is equal to 5, 7, 8. And matrix B is equal to 4, 7, 6. We cannot add these two matrices because sizes are not equal. Sizes are not equal. What is the size of the matrix? 3 rows, 1 column. That is the order of the matrix is 3 rows, 1 column. Here, 1 row, 3 column. So the orders of the two matrices are not equal. So addition is not possible. Subtraction is also not possible. I will explain in the next example how to subtract the two matrices, but now try to understand. So to add the matrix, the two matrices are of the same size. Same size. So we are required to say that matrix A can be added to matrix B only when the matrix A and matrix B sizes are equal. So next point, what I want to say, for example, I'm saying to say, so I will take a example, same example, example A. So A is equal to A, B, C, D, and B is equal to F, G, H, I. Now, what is size? 2 into 2. What is size? 2 into 2. What is A minus B? A minus B is equal to matrix A. What is a matrix A? This is a matrix A. First element with first element. A minus F. What is second element? B minus G. B minus G. Then C minus H. C minus H. Then D minus I. D minus I. So this is A minus B. What is the order? 2 rows, 2 columns. So if the matrix are having the same size, addition and subtraction are possible. Addition, subtraction are possible. Now you can ask a question, sir, why the matrix algebra is? What for matrix algebra has to be learned? So in case of computers or in case of numerical calculation, we have to store a lot of data. Lot of data should be stored in a particular location. So in order to store a data, we are required to create a memory locations. To make a memory locations, we are using matrix. For a particular matrix, we are giving a particular elemental memory storage, and for that memory storage we are storing the data in that elemental memory. So okay, all those things are not required for you, but as a general, so for the addition the orders are same, for multiplication for addition the orders are same, and for subtraction the orders must be same. Now I wanted to say one small idea, small bit of things I have to explain. So this matrix addition or matrix subtraction is done in the same fashion. So 3 by 3 matrix also be done in the same fashion. So we can go for a 2 by 2 matrix or for a 3 by 3 matrix. In the 3 by 3 matrix also, we can add the corresponding elements of the corresponding element of the first matrix will be added to the corresponding elements of the second element. Like that, we can do the addition. Try to understand. C cannot be added to F, or B cannot be added to I. A can be added to F, or A can be subtracted from F, or B, G, C, H, D, I. So this is regarding the matrix addition and subtraction. So in the next class, we'll go for matrix multiplication and transpose of a matrix and matrix multiplication. Okay. So in this class, we are concluding that matrix is a rectangular array of numbers enclosed within brackets, and their use is widely accepted, and it is having a fantastic application in the engineering and also in data science. Okay, that is the conclusion we come to this class. Okay, so by this class, by this I'll end the lecture, and the next video will go for multiplication and transpose of a matrix. How to transpose a matrix, how to do a multiplication in a matrix, that we'll do. Okay, thank you very much. Bye bye.